Today in Capechi's Corner, we're going to look at special functions, and this is our first day. A piecewise function is defined as a function that is written using two or more expressions, and within that, each interval or piece is defined by a different expression. So if we look at number 1, we have x minus 2 is one of our expressions, and we have x plus 3 is one of our expressions. And we have some inequalities that go with those specific expressions. So let's start with the first one. We have x minus 2, and we're saying x is less than negative 1. Okay, so we're going to start with our x value being negative 1. And we know it's less than and not less than or equal to, so we'll get to that in just a minute. We're going to substitute it into our expression. So we get negative 1 minus 2 gives me negative 3. Then I'm going to go with another one, a value that is less than negative 1. So I'm going to go with negative 2 next. So I get negative 2 minus 2 gives me negative 4. And I'll pick another value, which is negative 3, which I end up with negative 5. Okay, so now when we graph this negative 1, negative 3 is going to be right here, but it's going to be an open circle since that inequality is less than, not less than, or equal to. Okay, I'm going to plot my other points. So I have negative 2, negative 4, negative 3, negative 5, and I'm going to draw my line with my arrow on the end. Now with this, you can also see my slope, right? If I go back to my expression, my slope is 1. And if I look at the slope of this line, I go up 1 to the right 1, which is 1, up 1 to the right 1. Now, the interesting thing with this is if I were to keep going, then my y-intercept actually would be at negative 2. So it's kind of one way that you can double check, kind of just take a quick look at to see how you did. Okay? All right, let's look at the next expression. We have x plus 3. This time x is greater than or equal to negative 1. So I'm going to start with negative 1, and all my values are going to be greater than negative 1. So I'm going to do a couple. I'll fill in what I have as my y value. This gives me 3, and then I have 4. So I have negative 1, 2. This time it's going to be a closed circle, right? Because it says x is greater than or equal to negative 1. I'll plot my other points, 0, 3. 1, 4. And again, my starting point is there, so that's where I'm going to put my end point there, and my arrow goes to the right. Now again, if you look at this expression, right, if you made that y is equal to x plus 3 or f of x is equal to x plus 3, my y-intercept is 3, and my slope is 1, up 1 to the right 1. So that actually looks pretty good. So our domain values, we're not excluding anything. We're going all the way down here to the left, all the way up to the right. And again, I'm looking at this value right here for 1. Even though it's an open circle down here, I have a closed circle up here, so I'm including 1. So again, I'm not excluding anything. So my domain is going to be all real numbers. Now, when I look at my y value, my range, right, I'm going top to bottom. So I'm starting with 2, and I'm going up continuously, right? And here I'm starting with negative 3. I'm not including negative 3, but I'm starting there, I'm going down. So in here, I'm not including that. So I need to kind of list that separately and talk about the different pieces that I have, right? So my first piece, I'm going to say f of x, this is how you write it, such that f of x is less than negative 3, right? That talks about this piece right here, not less than or equal to, it's less than negative 3. Or f of x, and again, I started here on 2 and I have a closed circle. So f of x is greater than or equal to 2. And that is how you would name the domain and range for this particular piecewise function. All right, let's look at another one. Okay, so again, this time we're starting with 0, and I'm looking at numbers less than 0. So I'm just going to do that right away. I figure out what my function is, what my output is, my y value. So this gives me 2, this gives me 1, this gives me 0, and I'll graph it. So this 0, 2, remember I'm going less than 0. So that 0, 2 is my starting point, and that's going to be an open circle. Then I have negative 1, 1, and then I have negative 2, 0. Again, my slope in this case is also 1, so I'm all set there. Again, this is an open circle, right? Open circle. I'm going to do the same thing. It tells me that I have to start with 0, but this time I'm including 0. So f of x is equal to x, right? F of x is equal to x. So whatever my x is, My y value or my function of x is. So that's going to give me 0, 0. I'm going for values greater than or equal to 0, so I'll go with 1, 1 and 2, 2 just to make my life a little easier. So I have 0 here, and I have 1, 1 here, and 2, 2 right here. Draw my line. Arrows on the end. So again, in looking at my domain and range, I first have to decide, am I excluding anything? When I go left to right, here's a closed circle here and an open circle here, similar to what we had before. So there's nothing excluded, so we're going all real numbers. Okay, looking at my range, I go top to bottom, all along my y-axis, and it doesn't look like I'm excluding anything there. So that is also going to be all real numbers. Now we're going to take a look at writing the piecewise defined function shown on the graph, which I don't know, I think sometimes is a little harder. Like when you did graphing a line, is it easier to graph the line or is it easier to write the equation of the line? So we'll see. So we have to start off with, again, our notation f of x is equal to, now in this first one we have two different pieces going on. So let's just start, here is the origin. First, let's make sure we know where that is. That's right there. So if we start with this first one down below, I'm going down 1, 2, 3, 4. So my y-intercept is -4. My slope is up 1 to the right 1. So I know that's 1, or 1x, so x. Now I have to figure out where I'm going. I'm starting at 2 here, right? My x value is 2. And I'm going to the left. So anything less than 2. I have an open circle. So it's going to be if x is less than 2. Now let's take a look at our next line. Now this is actually a horizontal line. So although sometimes that you think that's going to be a little harder, I actually think this one's easier. I start at my origin, I go up. So my equation of my line, I'm just going up 1. So my equation of my line is f of x is equal to 1. Now again, if we start with at origin, we went over 2 spots. So again, we're starting at 2 and we have a closed circle. So x is greater than or equal to 2. So that is our piecewise function defined. All right, let's look at one more like that. So let's again go to, let's see, we're going to do f of x is equal to, now this time there's 3 pieces. So we just have to be careful. Let's start with this big line up here. So again, here is my origin here. And it looks like I went up 1, 2, 3. So it looks like my y-intercept is going to be 3. I have to figure out what my slope is. So from here, it looks like I go up 2 to the right 1. I can try again, down 2 to the left 1. So that looks pretty good. So my slope is positive 2. So 2x plus 3. Now we have to figure out where do we start with x. So my x value again looks like it's right here. So we're looking at 1. So we have x, and that's an open circle, is less than 1. So f of x is equal to 2x plus 3 if x is less than 1. All right, let's do another one here. Let's do that line. That line is at 1, 2, 3. So f of x is equal to 3. Now again, where did I start? 1, 2, we started at 2. So we're going to say that x, again, it's an open circle, is greater than 2. So my line is f of x is equal to 3 from 2 and to the right, but an open circle. Now our last one is a little trickier because of the fact that there is no y-intercept. So it looks like my slope here is 1. So if I continue up 1 to the left 1, it looks like my y-intercept there is at 2. My slope would be down 1 to the right 1, down 1 to the right 1, so that's negative x. Now this doesn't have an arrow on that, so I definitely have to, on the end, arrow doesn't have an arrow in there, so I'm defining it's actually only between x is equal to 1 and 2. So I have, let's give myself a little bit more room here. Let's do if, and I'm between 1 and 2. So I just have to check out my signs. I have a closed circle for both. So I have less than or equal to there and less than or equal to there. So again, you just kind of want to double check everything, make sure you're okay. And that is our second piecewise function defined. So there we go, some extra practice. The last problem we're going to look at today is a word problem. It says an automotive repair center charges $50 for any part of the first hour of labor and $35 for any part of each additional hour. Draw a graph that represents the situation. Now, this looks overwhelming, but let's just think about this. And this happens a lot of times in the real world, whether you're taking your car in for some repairs, or whether you have a plumber coming to your house, they're going to charge you for the first hour of labor at least. Anyway, because they're not, if they come to your house and it takes 10 minutes, or they realize, they don't have the equipment they need, or that you need something replaced, they want at least, it has to be worth their time. So they want to come in and at least get paid for that first hour. So anything after that gets paid $35 for every hour. So that first hour is going to be anywhere from from them walking in the door to the full first hour. So that's going to be $50. So after that, think about it. After that, if they're there for 1 hour and 10 minutes, or 1 hour and 50 minutes, or a full 2 hour, they're adding $35 to that. So let's look at our table, and that's going to give me $85. Anywhere, again, not including 2, but 2 hour and 10 minutes, or 2 hour and 20 minutes, or 2 hour and 50 minutes, up to 3, they're going to add, again, another $35. So now we're going to be at $120. Let's put our little dollar signs. Now the same thing, we go from 3 to 4. We're going to add 3 to 4 hours. We are adding another $35. So now we're at $155. And again, the same thing, anywhere from 4 hours to 5 hours, including 5 hours, we're going to be at $190. So our table is going to help us when we're graphing. So let's go back. So 0 to 1 hour, we've graphed here already. I'm starting anywhere from 0 to 1 hour. I'm at that 50 mark. It's going to be, horizontal line. It's going to cost you $50. Now, if I go into that anywhere from 1, and again, I'm estimating I'm at about $85. So from 1 hour and 10 minutes to 1 hour and 50 minutes, all the way to 2 hours, it's going to be cost $85. Same thing happens when I go between 2 and 3. So I'm at 120. So again, I have an open circle at 2 because I'm still paying the previous fee, all the way up to $3. And the trend continues from 3 hours to 4. I'm doing 155. So somewhere up there. And then the last one, from 4 to 5 hours, I'm paying 190. So again, this is called a step function because it looks like a step, right? It looks like steps going up. So again, this overlapping region here, up to 1 hour, you're paying that $55. And as soon as you jump to 1 hour and 1 minute, you're paying that next $35 in addition. Okay, so there's your step functions. Now it's good. Look at our X and Y axis. I probably should have started with that. I have hours are on my X axis, and the total amount charged is on my Y axis. So that's it for today.